Hello everyone, welcome back to Olsen Cafe. Today, let us solve this unstructured question on circle. It is a short question, but it requires your understanding of a very important concept students usually miss. Let us do a quick recap. How do we pin down the exact point for the center? Now, in my previous short, I showed that if we have a chord and I draw a perpendicular bisector for this chord, and I do have another chord, let me draw another perpendicular bisector for this chord, and what you will notice is that these two perpendicular bisectors will meet at a point, and this point is known as the center. All right, so which means, all right, I mentioned before, all right, for one perpendicular bisector, it will give us a line. Whereas when I have two perpendicular bisectors, this will be able to help me find the center of the circle. So always remember, center always lies on the perpendicular bisector of a chord. Now, so let's take a look at this question here that we are going to solve today. So I am supposed to find the center of a circle that passes through the points A and B. So let's assume point A is here and I have point B here. All right, and what do I have? So if I have a center that lies on the line, all right, which is y equals to 2x minus 1, let's assume that this is the line over here. So if this line is given, so I have two perpendicular bisectors, and over here I will be able to find the center of the circle easily. Now that we have a better understanding, all right, that the center lies on the perpendicular bisector of this chord, we are ready to go through the steps to find the center. All right, and the question says that the center lies on the line y equals to 2x minus 1. So let me sketch a more accurate, all right, line, all right, y equals to 2x minus 1. So with this, all right, I do know that the center is the intersection of the two lines. Okay, so with this, it simply means that, all right, what I want to do, all right, will be to solve simultaneous equation. All right, so simultaneous equation of, all right, the equations of this perpendicular bisector of A and B together with the line y equals to 2x minus 1. So with this, I will be able to find, all right, the center of the circle. So do take note over here is that the diagram that I've shown you here is not drawn to scale. All right, it is actually meant for visual purposes only. So what we do need to do right now is to find the equation of the perpendicular bisector of A and B. Now, perpendicular bisector, it simply means this line here is 90 degrees to the chord. Now, how about the word bisector? Bisector, that means, right, the line will cut through the center of the chord AB. So, which means, based on this, I will need to first find the midpoint of AB. So with the midpoint of AB, in order for me to find the equations of this perpendicular bisector, I will also need to find the gradient of AB. With gradient of AB, I will be able to derive the gradient of this perpendicular bisector. So with this gradient and with the midpoint of AB, I will be able to find the equation of the perpendicular bisector. Yeah, so let's continue to solve here. So let's work on the midpoint of AB. So I do have the coordinates of A and B. So to find midpoint of AB, all right, I have the formula. This will give me, all right, x1 plus x2 divided by 2, and I have y1 plus y2 divided by 2. So I simplify this. This will give me the midpoint equals to -half and 8. Now, so once this is done, let's proceed to find the gradient. So gradient of AB, I use the formula. So it's simply y1 minus y2 divided by x1 minus x2. So 0 minus minus 1. So therefore, this gives me 0 plus 1. So I simplify this, I will be able to get the gradient of AB, which is equals to 2. Now, how about gradient of perpendicular bisector? Now, gradient of perpendicular line, right, is actually the negative reciprocal of the gradient of AB. So which means if a negative reciprocal, so which means it is actually -half. So make sure you know this well. Now, so Given this, I have the midpoint and I have the gradient of the perpendicular bisector. I put this together. I do know that to find equations of perpendicular bisector, I will have y equals to negative half, which is mx plus c. And I do have the point, which is the midpoint, negative half and 8. So putting all these together, all right, you will be able to get the equations of the perpendicular bisector. All right, so I'm simplifying my working over here. So you should derive the equations to negative half x minus 31 over 4. Not sure if you are able to get this equation. So with this, that means I have this line. All right, I have this perpendicular bisector. I also know that this line is given y equals to 2x minus 1. So I have already found equation of perpendicular bisector. And now the line y equals to 2x minus 1 is given. Are we able to find the center of the circle? So what I'm going to do is I will leave this part of the working to you. So you just simply need to solve simultaneous equation. Let me know in the comment below what is the answer that you get for the center of the circle. Hope you find this video useful. Do like and subscribe if this helped you. Alright, I will see you in my next video. Bye.